welcome back to the St. Pete Science Festival. This session is all about karst, or what lies beneath our feet. And we have researchers here from the University of South Florida to take us away. Don't forget to use the chat for questions, and off you go.
Hi everybody, I'm Dr. Van Benen from the University of South Florida School of Geosciences. As you heard, we're going to be talking about karst today. I'm joined by members from my karst class. We have Ashlyn, Sarah, Olivia, Stan, and Ying, who will be talking about different aspects of karst. So what I'll do now is I will share my screen, hopefully, and everybody can hopefully see this video. Give me a second. Whoops, sorry. Yeah, here we go. Oh, right, here we are. Yeah. Right, is everybody ready? Okay, go.
As you can see from this model of Florida's landscape, karst is land that has distinctive landforms and water movements. Caves develop when carbonic acid comes into contact with carbonate rock. Carbonic acid is made when rain picks up carbon dioxide. It is similar to soda and can wear away the rock. Carbonate rock is a type of rock that is soluble, meaning it will dissolve when the acid touches it. This creates caves and sinkholes. The acidic water flows down the path of least resistance, such as small fractures and bedding planes, or the horizontal layers in the rock, as shown by the laser pointer. Over time, as more and more water flows through these fractures and bedding planes, they widen, creating large holes in the rock. Caves, sinkholes, and shafts are where rock was dissolved, resulting in the widening of these features. There are different types of sinkholes. They are created when the carbonate rock below the surface is dissolved and covered under a layer of sand or soil. Bigger holes can lead to large sinkholes that you see on TV. Smaller ones occur when soil slowly filters down into the hole in the rock. These cause cracks in houses, which means that the holes have to be filled with concrete. There are two sections that you need to know to understand karst. The first is the saturated zone. This area is filled with water and is called an aquifer, meaning water saturates an underground layer of rock in deep caves. Springs are where the water from the aquifer comes out. You can see this on the left-hand side of our model. Aquifers and springs are very important because we use the water from them in many ways, such as in our houses. The second section you need to know is the unsaturated zone. This area does not contain water and is the topmost part of the karst system. Stalactites and stalagmites develop here. As humans build cities and towns, they change the environment, often in a negative way. Humans can cause damage to karst in a couple of different ways. Pollution is the main way humans damage karst systems. Waste can flow into the aquifer and spring from water runoff. Pollution can come from farms, fertilizers from lawns, and factories. Here in the model, you can see how people impact our aquifer as shown by the dyes. Take a close look at how the dyes that represent pollution interact with the water in the aquifer. Red dye represents factory pollution, and yellow represents farm and lawn pollution. You can see how the dyes mix with the water in the aquifer. Humans also use a lot of water to drink and for things like farming. We can impact karst by pulling out too much water from the aquifer through wells. This could cause the rock to sink as the water isn't helping to hold it up anymore. Sometimes humans even damage caves by writing on the walls and breaking the rock. However, one way that humans interact with karst in a non-damaging way is by underwater cave diving, as you can see in our model. Next, we will look closely at different parts of a cave.
Caves are unique underground places and are home to many different organisms. These organisms come together to create unique ecosystems, which are also very fragile. This doesn't mean they're breakable like glass plates, but that the ecosystem can be easily disrupted. We can see these cave goers going down into the cave. Caves are dark, damp, and have stable climates, which force these organisms to adapt, leading to changes in the way they look or live to make their time living in the cave easier. As we investigate this cave, we can see many of these animals have adapted to living in the conditions that the cave provides. All the organisms we're about to look at come from different places like South America, New Zealand, and the United States. Let's get a closer look. This is the whip scorpion. The whip scorpion has long antennas that help them find prey in the dark. The scorpions are also nocturnal hunters, but are not poisonous or dangerous to people. Cockroaches are scavenger bugs and like to feed on guano, aka bat droppings. The blind crayfish has no eyes and no coloring due to the darkness of its surroundings. It doesn't have to see. The lack of sun also makes it lose its color. The red cave salamander has long limbs to climb about rugged rock. The Texas cave beetle is also blind like the crayfish, which has no eyes because of how dark it is. Besides all the living organisms we see, we can also see bones of ones that are no longer living. The bones we see here are the baby moa, the largest bird that ever lived, which humans hunted to extinction. Fossils that have been uncovered from underground can show us what used to live above and within the caves. Caves are usually found in limestone, which have created shallow tropical seas and all the animals that lived in them. Evidence from this is a shark tooth fossil that we see here on the wall. The giant centipede found in Borneo, Asia, is highly poisonous. You can also see glowworms. Glowworms are insects that have larvae that glow with bioluminescence. Their larvae spin long fishing line webs and trap their prey. You can also see bats. These small brown Florida bats look like they are part of a colony. Bats like to colonize in caves, don't live there all year, but nest here and hibernate in the winters. Without the unique environments, these organisms have a hard time living there.
Here we have our speleology exhibit. We will be primarily discussing some of the most prominent features of caves, stalactites and stalagmites, and their formation process, along with other speleothems. First, in the upper right corner of the cave, you can see a helictite. Helictites are formed the same way as stalactites and are made of the same minerals, calcium carbonate. This is the stuff what your bones are made out of. What makes the helictites different from stalactites are the odd ways they grow, which appear to defy gravity. To this day, it's still a mystery on how they get their shape. If you draw your attention to the center of the cave, you'll see icicle-shaped formations protruding from the rock. These are called stalactites. Stalactites are formed from water percolating through rock and dripping down into the cave. Stalagmites are the rounded mounds beneath them and are formed via the same process. They typically form at a very slow rate of hundreds to thousands of years, but given long enough, the stalactites and stalagmites can touch and create a column. Here beneath the pond, you can see cave pearls. The cave pearls get their name from sea pearls because they form in the same way. Tiny bits of grit and pool water attract the calcium carbonate supplied from water dripping from stalactites. In addition, the moving water in the pool can polish the pearls, giving them a glossy appearance, hence the name. If you look closely, you can see a cutout of a real-life stalagmite. Notice the thin layers of deposited calcium carbonate. These layers can help us find the age of these stalagmites using different dating techniques. These thin structures are essentially stalactites in juvenile stage and are extremely fragile. Due to their shape, they are commonly referred to as soda straws. As mentioned earlier, stalactites are formed from water percolating through rock, dripping down into the cave. These water droplets are fundamental to the formation of stalactites. Water percolating through rock is rich in carbon dioxide, and when it interacts with the limestone, it creates a solution that is rich in calcium through a dissolution process. As this water enters the cave, the CO2 leaves the water, after which the droplet deposits an ever so slight amount of calcium carbonate.
So here we have the first signs of humans using caves. People have used caves for thousands of years, and one of the reasons we know this is due to the art that can be found on cave walls and ceilings. Pictured here is an illustration of how Neanderthals used caves for shelter, and this is where the cave art would have been produced. The first evidence of cave art was seen in Europe around 35,000 years ago in places such as France, Spain, Germany, Italy, and Russia. Some caves have a couple of pieces of artwork, and others have hundreds of drawings and paintings. The cave art was often produced using charcoal from the remains of fires, and pigment was often added to the charcoal for colour. One pigment often used was ochre, as well as manganese and iron oxide, which produced black and red pigments. Most cave art paintings were produced with these two colours. The raw material was often broken down into a powdery form and then washed to get rid of impurities. It then needed a glue for the powder to stick, and often spit, blood, or urine was used for this, although charcoal could be directly put onto the wall with no binding agent. The people would then use their fingers or hands to smear the liquid onto the walls or use twigs like a paintbrush. Brushes were also made with the use of hair or bristle, and animal fur was used as a sponge. Another method was to spray the pigment from their mouths after chewing it. The choice of artwork tends to mainly be animals, specifically large herbivores such as horses, mammoths, and deer, and they are all from a side profile view. Most of the hand drawing or human-related drawings were only half complete and often unnatural looking compared to the detailed animal drawings. Strange marks are often found in caves, and some people speculate that this may be an early form of writing. One theory of why cave art is there is that it was used to teach young hunters, or it is evidence that they had a belief system. Often animals are depicted in the paintings, and the people may have drawn this as it is a representation of the food and raw materials that people use, along with the animals that were a threat to them. Paleolithic paintings such as stencils of hands can be found in caves in northern Spain, as seen in the video. These were produced by blowing paint onto the walls, and these have been dated at around 40,800 years old.
All environmental systems have been impacted by human activities, and caves are no different. It is possible to destroy entire caves. Cement that needed for concrete comes from limestone quarries. If a cave is found in the quarry, it can be destroyed as rock, that is, the cave homes blow up to make cement. This happens in Florida. People going into cave will always impact the cave, even if they are very careful. Simply touching stalactites and stalagmites can damage them. Many cave critters live on cave floor, so even crawling or walking will have a negative effect on them. However, often people are not careful and vandalize caves. This can be seen in the graffiti, broken stalactites and stalagmites, and the trash in the cave. Visitors in the tourist cave have direct physical effects such as the introduction of concrete and steel structures, transport of mud, dust, and nutrition using artificial lights, and breathing out carbon dioxide. In the old days, some tourists might cut small pieces of cake as souvenir, which damages the cave. They also use soot from the flaming torches to sign their name on the cave roofs. And as the time goes by, the footsteps of tourists could wear down and break the rock into little pieces. Unlike the surface environment that is very changeable, cave environments are constant. It is a world of total darkness, constant temperature, and high humidity. The animals that live in the cave must not adapt to this condition, but they must also live in an environment where there is very little to eat. All species in the cave system are dependent upon each other for survival. When people occupy parts of a cave as tourist areas, animals that live in the cave must get away from that area because human activity is always combined with noisy sound, light, which scares them away. If a cave animal cannot find a suitable place to live, the population of them will decrease, which will negatively affect the cave ecosystem. Some cave animals may even go extinct. People coming and going from the cave can bring disease in the cave that can badly affect the animal living there. The most common problem is something called white nose syndrome that you can see in the roosting bed in the cave. This disease is a fungus that invades the beds, making them wake up when they are sleeping during the winter. This makes them the fat reserve, meaning the best star. The fungus can destroy the best wings. Almost 7 billion bats have died since 2006 from this disease, which we can almost likely introduce to the caves. To sum up, human activities will always have negative effect cave environments, but as long as we're aware of this, we can minimize these effects.
All right, thank you. Here's just the pictures of the people who are actually kind enough to work on this. So we have the Karst research group, the School of Geosciences, the previous Karst class from 2019, and the current crop who are working with us now. Okay, so do we have any questions?
Thank you for that awesome video and narration. I have never seen caves here in Florida or understood anything about Karst, so I just learned so much. And we do have a few questions, and I hope more will come in. So the first question is, how does the earth not cave in if there are so many caves underground?
Okay, I'm just asking if anyone in the group actually wanted to answer that question. Well, a lot of the earth is not karst. Only around maybe 10% of the land surface is karst. And when you think about that, 75% of the world is oceans. So that only leaves 25%, and then only 10% of that is actually karst. And most of that is actually does not have caves across the whole of it. And these caves can be quite deep. Like some of them are like thousands of meters deep. So that means there's a lot of rock on the surface to stop things from collapsing into them. But it does occasionally occur, as you saw in the first part of the video. You could see that there was actually a sinkhole with rubble that had fallen down to it. So it does happen, especially here in Florida, where we have sinkholes.
Hello, back again. Apologies
Good.
for internet issues. I was just fine for a moment there. Thanks for that. Did you finish answering while I got kicked off?
I did.
Okay.
I did. Yep.
Awesome. Thank you. Have another question. Are the animals in the caves born there? And is that what, like, why they have adapted there?
Okay, so I guess I'm taking this question as well. Yes, some of them are actually born in the cave. For example, the glowworms are, which are, those are the ones who are in New Zealand. I think the bats are actually also, I think they breed in the caves. So I think they may be born there as well, or they don't live there for their entire lives because they come into roost at night. During the day, and then they fly out at nighttime. And some of you have probably seen bats flying about in your neighborhoods, but they do hibernate also there. Things such as the crayfish, that was the blind crayfish, the beetle, the Texas beetle, they are adapted to live in a cave, so they are absolutely born there. Some of the animals, such as the whip scorpion or the red salamander, we're not actually totally sure about that.
Awesome, thanks. It's really cool to see all those animals and think about them down there right now beneath our feet. Okay, another question is, did the cavemen draw on the stalactites themselves?
Sorry, I couldn't quite hear you cut out for a second.
Okay, did the cavemen draw on the stalactites themselves or just the walls?
I believe they just painted on the walls, not actually on the stalactites. So it was more they were using the walls as a canvas almost. So they would use that to explain their story or to explain to the young hunters of how to hunt and what animals to look out for. So it wasn't on the things in the cave, but more on the walls and the ceilings.
Awesome, thank you. Okay, other questions. How did the animals actually start living underground?
That's a very good question. They probably went into the caves initially to shelter or to breed, and as they were talking about evolution, that was over millions of years, potentially for some of these animals, you know, they probably found it as a great place to live, that they weren't preyed upon or eaten by other animals. So then over, you know, hundreds of thousands of years, they started to adapt to that environment. And then they started, you know, like the cave, the crawfish and the streams, they then just started to adapt to that. Some other animals got really, really long legs. Others had big antennae so they could find their way around in the dark. So yeah, they definitely had to evolve and adapt to that environment, but it would have taken a long, long time.
Got it. Another animal question. How many different species of animals depend on caves to survive?
Literally, we don't actually know that, and there's a very important reason why. It's because a lot of caves have not been explored. We don't actually know what animals are there, especially ones that live in the water, because there's an interesting reason why. Because we can't go into all places of the cave. Not all caves are large. Like, you know, we showed an artificial cave here that the students built over a couple of years, but most caves, a lot of caves have areas where we just can't crawl into. That's the only way you'll find a cave is by crawling into it or dive into it. And we don't really have the capability to go into all those places. But I can safely say that there are thousands of different species, and then, you know, probably 50 species are discovered every year that we didn't know about.
Awesome. Okay, I think we have time for one more question, and that is about how the water actually gets through rock and dirt to then form underground structures. Does the water do that, or does it fill the structures? How does that work?
You want to do it? Okay. Well, Stanley will answer that question quickly.
Thanks, Stanley.
Hello. Hi. So essentially, water, could you repeat the question one more time? I'm sorry.
That's okay. So how does the water get through the rock and dirt, and how does it then, or does it then form underground structures?
Okay. So the easy route, there are a couple of ways. Water travels to the path of least resistance. So a lot of these rocks and dirt and everything have little cracks and slivers in the rock, so water can kind of find its way down. A lot of rock also are very porous. They're not always very sturdy and thick. A lot of them have high porosity. I'm trying to explain in a very easy term. But anyways, water finds its way through rocks, through cracks and slivers. Another way is a dissolution process, which I've explained earlier was some of the water can be a little acidic, and over time, the water breaks down the rock and kind of creates conduits or paths for the water to travel down. And as it travels down, the water picks up calcium carbonate, and as it drips, it's a very long process, but as it drips down, it deposits, every tiny little drip leaves a little bit of calcium carbonate, and that's why it forms icicles. So yeah, that's how we get stalactites and stalagmites.
Awesome. Well, thank you so much to the entire team for sharing all of your knowledge about Karst. Yes, we want to see you.
Come on in, guys. Come on in.
Thank you all for sharing your knowledge about Karst. And I hope that if folks have more questions, they can reach out to Dr. Van Benen and ask them, and the awesome students that you're working with. So thank you all. Have a good rest of your day, and we'll be back soon with more St. Pete Science Fest.
Okay, thank you very much.